4.8. Similar triangles. Similar triangles. So not only are we able to prove that triangles are congruent to each other, but we're also going to prove that triangles could be similar. So the first thing I want to talk to you about is like, how do we prove that triangles are congruent? What are the theorems or the postulates that we use? So how do we prove triangles congruent? Well, we use, let's see, the first one you learned was side, side, side. And then what did you guys learn after that? You learned side, angle, side next. Then you learned angle, side, angle, and angle, angle, side. The last congruence proof that you guys learned was specifically geared for right triangles. Do you remember what we called that one? Yep, HL, hypotenuse leg. So basically, you need 3 elements. Basically, you need 3 elements to prove triangles congruent. And that's exactly what we put on our little green foldable thing that you got to use on your quiz yesterday, which you guys don't want to lose that because you get to use it on your test. Okay. And we're going to make another one on Monday. Okay. And I don't have any copy of filled out notes. Thomas, you probably don't have your note packet, do you? All of the copiers were being used. We only have 2 copiers that work up here, and they were both like being sucked up during my. Well, I had to go down and cover a class during my planning, honestly. So when I came back up, all the copiers were being used. So I will get you some fill out notes when we're done with this. Thomas, I'll send what I write. So if I typically give you fill out notes, you're gonna have to wait till afterwards. I'll send them afterwards, okay? Okay, so we're going to learn today that we can not only prove that triangles are congruent, but sometimes we don't have congruent triangles, but instead we have similar triangles. So remember that congruent is this symbol, right? This is the symbol that we use for congruent. Well, when we want to say that triangles are similar, we use this symbol. That's the symbol for similar. Okay. If triangles are similar, we still have 3 pairs of congruent angles. If they're similar, their angles are still congruent. Okay. You have to have 3 pairs of congruent angles. But the sides aren't congruent. Instead, they are proportional. They are proportional. Okay. So we have 3 postulates, or 1 postulate and 2 theorems actually, that we use for for triangle similarity. The first one is angle similarity. And if you remember when we first started talking about using the angle theorems, we had a couple in our homework that had all 3 angles congruent to all 3 angles. And we wrote specifically, oh, that doesn't prove congruence, that only proves similarity. So if angle A is congruent to angle F and angle B is congruent to angle G, then I can say that triangle ABC is similar to triangle FGH. That's what angle similarity looks like. Okay. We also have side similarity. Not just side congruence, but side similarity. So remember the rule about if triangles are similar, their sides just have to be proportional. So segment JL corresponds to segment MQ. So JL has to be proportional to MQ. JK corresponds to MP. So JK has to be proportional to MP. And the last one, LK, corresponds to QP. So LK has to be proportional to QP. Now, do you guys remember setting up like solving equations that were proportions and you did that cross multiply? That's how we solved an equation that was a proportion as cross multiply. It's kind of the same idea. The most important thing to remember is that if you put the large triangle measurements on the top and the small ones on the bottom, you got to keep following that same pattern, right? So if JL corresponds to MQ, then you can't put MP on the top and JK on the bottom. Large on the top, small on the bottom. And that's how I always set it up. Large on the top, small on the bottom. I don't know. That's just how we were always made to do it. The last similarity is side angle side. So remember that the angles are congruent. The angles, so angle S is congruent to angle Y, but the sides are proportional. So remember I said I always do the large to the small. So XZ has to be proportional, like this side compares to RT, which means that YZ has to be proportional to ST, which means that YX, well, how about XY, has to be proportional to RS. Okay. So we're just setting up proportions. We're just setting up a proportion. Okay. So when I think about wherever the angle is, so if I'm using side angle, side similarity, I'm really focused on XY and YZ. I'm really focused on the XY and the YZ. So we're going to just practice that. We're just going to use that idea and practice it. So our first example says, determine whether the triangles are similar, and if so, write the similarity statement. So I'm going to first off write down the 3 theorems / postulates that we use. So we have angle, angle, similarity. We have side, 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 similarity. And we have side, angle, side, similarity. So when I look at this first pair of triangles, you see that you have 2 parallel sides. You have 2 parallel sides. Well, if this side, if these 2 segments are parallel to each other and this is the transversal, that means that this angle right here is congruent to this angle, right? What theorem is that lets me say that? Well, they're on the inside of the parallel lines and they're on opposite sides of the transversal. That's alternate interior. But what if this is the transversal? Well, that means that these 2 angles are congruent. They lie in between the parallel lines and on opposite sides of the transversal. So these 2 sides are congruent, or these 2 angles are congruent to each other. But we also have this thing called vertical angles. And I know that these are congruent to each other by vertical angles. So I know that triangle XYZ is similar to triangle WVZ. And I want to talk to you about how I name that by angle, angle, similarity. So you have to follow the triangle. Remember, when you name your sides or when you name your vertices of a triangle, you have to follow the pattern. So I did X, Y, Z. X is the baby blue angle, so it corresponds to the baby blue angle, W. Y is dark blue, so it has to correspond to the dark blue angle, which is V. And then Z is the vertical angle. Okay, so you have to be really precise about how you name it. What about our next example? What about our next example? Well, we have a right angle here and a right angle here. What do we know about right angles? They're what? They're congruent to each other. They're congruent to each other. So do you guys see that you have the legs? You have marks on the legs. One is 3 and one is 4. On this triangle, you have one leg that's 6, but you don't know the other leg. How could you find it?
You add 4. Should be 8.
What theorem lets you find the missing side of a right triangle? Well, yes, but what theorem is that? No, Pythagorean theorem. A squared plus B squared equals C squared. You have to prove, you're telling me what you want that side to be. So they're proportional. You have to prove what that side is. You first of all have to figure out what that side is. So the legs, 6 squared plus x squared, have to equal 10 squared because the hypotenuse is always opposite the right angle. Well, 6 squared is 36 plus x squared equals 100. When I subtract 36 from both sides, I find out that x squared is 64, which means that x is 8. So this measure is 8, and we proved it. So now when I compare my short side to the short side, short leg to short leg, it has to be proportional to the long side to the long side. Let's see. 6 times 4 is 24, and that equals 8 times 3, which is also 24. So these are proportional. Your sides are proportional. And you have a congruent angle. So this is side, angle, side, similarity. Side, angle, side, similarity. Number 3. So I have 3 sides, 3 sides. So I would do it like this: small, medium, large compared to small, medium, large. You only need 2 fractions, right? So 6 is to 4 as 8 is to 5. Let's do cross product. What is 8 times 4? And what is 6 times 5? 30. Does 32 equal 30? No. So these are not proportional. These are not proportional. You can't prove that they're similar. So if they're not proportional, that means that the triangles are not similar. Okay. How are we going to set up the next one? What do you think, Tyler? How do you want to set it up? Just pick 2 sides of one triangle and compare them to 2 sides of another triangle. Just make sure that you do the small side of one triangle to the small measure of the other one, okay? So which one do you want to compare first? Okay, so what side do you want to start with? What measure do you want to start with? So 4, that's the smallest measure. So what's the smallest measure on the other triangle? 10 equals, what measure do you want to pick next from the SRQ, Tyler? You already used 4, so you either have to use 8 or 6. 6, okay, that's the medium side. So what's the medium side on the other side? Okay, let's cross multiply. 10 times 6 is, 4 times 5 is, 4 times 15 is. So I proved that these 2 sides are proportional. What do I have to do? Do only 2 sides have to be proportional, or do all 3 sides have to be proportional? All 3. So how about if we use that first proportion you set up, 410, and compare the 820? You got to compare all of them. Let's see. 4 times 20 is 80, and 8 times 10 is 80. So now you've shown that all 3 sides fit the proportion. So triangle, You said you wanted to do SRQ is similar to, how are you going to name the other triangle? So you went through the small side, through the medium side, through the small side, through the medium side. Do you see that? So it's not JKL, but it's JLK by side, side, side similarity. Okay. Are you not writing it down?
No, I'm trying to see if I can. I'm gonna see if we put all three of them in one thing. See if they equal like the same thing.
They all equal the same fraction. 2/5, which is 0.4. 0.4, 0.4, 0.4.
See what I'm saying? Like you put 4 over 10, and then 8 over 20, and then 6 over 15, and then you can get a 4 times 20.
You can, but listen to what I'm saying. Guys, listen to what I'm saying. What is 4 divided by 10? Well, 4/10 is 0.4. What is 6 divided by 15? It is 0.4. What is 8 divided by 20? That's how you know that they all are all proportional. They have the same, because what's that called? It's called the scale factor, right? Proportionality is the same thing as when you enlarge or shrink something, right? Similar is when you make something bigger or smaller, like dilation. That's how you need to think about it. So let's look at this next one. This next one, I have this angle right here. Angle X is congruent to angle J, and angle Y has a measure of 51. That's congruent to angle K that also has a measure of angle 51. So do we have angle similarity? Huh? Yeah, we have angle similarity, but we have side measures in there. How are we going to compare those? How are we going to find this measure? They're not right triangles. So what if I orientate this triangle the same way? So I'm going to take this triangle right here and I'm going to do a rotation on it. So J is at the top. I need K to be over here because it's got to line up with this one. And that means L is right here. So J is at the top. It's proportional or congruent to X. L can't be on the left side because K is congruent to Y. Do you see that? K and Y are congruent to each other. So let's see. Side JK is 4 and side YZ is what? 5. We don't know what side KL is, X, but we know what side YZ is. So can you figure out, you know that they're similar. So now you have to figure out the missing sides. So you already proved they're similar by angle similarity. Okay. You know that triangle XYZ is similar to triangle JKL by angle similarity. Now you have to find the missing measure. You have to find the missing side. We'll set up a proportion. 5 over 4 has to be equal to 15 over X. Four times 15 is 60. 5 times X is 5X. Divide both sides by 5, and what do you find out? What does X have to be? 12. X equals 12. So now you're told that the two triangles are similar. You have to say Y, and then you have to find the missing measure. Okay. Is everybody good with that one? Okay, so I'm going to move to the next one. Kane, what time are you guys leaving it? Isn't it 2:15? Okay. So the next one, you have a right angle and you have a right angle. but you also have angle S congruent to itself. So think about how these triangles are. This is triangle QVS, the big triangle. And then you have triangle RTS, the little triangle. So V and T are both right angles, and S is congruent to itself. So have you proved that the two triangles are similar? Yes, you have. Triangle QVS is similar to triangle RTS by angle similarity. Now we have to find the missing measure. So let's see. I know that I have a side of 5 and a side of 3. So 5 is to 3 as, if this is 5, this is 3. TS is 12. What is this measure right here? The VS measure. What is the measure of segment VS? What's it called? X. So that's what we have to set up. X over 12. So 3x equals 5 times 12 is 60, which means x equals what? What does x equal? 20. X equals 20. We're going to do 9, 10, 12, 13. We're going to do 9, 10, 12, 13. So number 9 and 10, it says determine whether the triangles are similar. And if they are, write the similarity statement. If not, what would be sufficient to prove they were similar? Meaning, what else would you need? Okay. So, are the triangles similar? Well, let's just do this whole big comparison. So I have 8, 5, and 10 all over. What are the measures of the large sides? What's the side that compares or corresponds to side 8? What's the measure of this side? It's not 3.2. It's the whole side. So it's 8 plus 3.2. Do you see that? What is 8 plus 3.2? 11.2. What's the whole side that corresponds with 5? 7. And the whole side that corresponds with 10? 14. So do that whole trick that Parker and I were talking about. What's 8 divided by 11.2? What's your decimal? 8 divided by 11.2 is what? What is it? 0.714. Okay, what's 5 divided by 7? Okay. What's 10 divided by 14? Okay. So do they all have the same decimal? Like, I know it goes on forever, but do they all work? Yeah. So this is proportional. So that means they're similar. So yes, they're similar by side. What about number 10? Can you prove that those are similar? Well, we know that angle A is congruent to angle A. What would what's one thing that I could say about segment B, G, and DF that would let me prove that those were similar? What if I said that segment B, I think it's a C actually. What if I said that BC was parallel to DF? Would they be similar then? So let's say that. If BC was parallel, we don't know that. They look like they are, but you don't know it. If BC was parallel to DF, then the triangles would be similar by angle. That's what it's saying by what could you use? What do you need to prove it? You would need to know that those two segments are parallel to each other. Okay. Number 12, determine whether the triangles are similar. If so, write the similarity statement. If not, what would be sufficient? So look at example number 12. Let's see. I know that angle J is congruent to itself. And if segment KP is parallel to segment LM, then I know that this angle corresponds to this angle, which means they're congruent. And this angle corresponds to this angle, which means they're congruent. So JKP, triangle JKP is similar to triangle JLM by angle similarity, right? What about this next one? Well, this is kind of tricky. You have a 62 and a 62, and then the other, like if you look at this triangle, the larger triangle, notice that the side measures are on opposite sides of the angle. So that would be like a side angle side similarity. But is it set up the same way over here? Are the are the side measures nestled on either side of the angle? Do you guys understand what I'm asking you? Okay. This is my congruent angle. And I know that this side measure and this side measure. So this would be like a side angle side similarity. Okay. So let's look at the next triangle. The next triangle has this angle. So I know that the two angles are congruent because 62 equals 62. But do I follow the same pattern? Do I know the measures so I can do a side angle side similarity? No, I don't. So this one is not possible, because you don't know anything about that triangle to figure out the missing side. All right. You don't know anything about that triangle to find out the missing side. I want you guys to do pages 43, 44. You're just going to do 43 and 44. 43 and 44. And I want you to do number 1 on page 47 to prove. So 43, 44, and number 1 on page 47. I need to adjust the, So homework is going to be pages 43 through 44 all, and, oh, dang it.